All right, guys. What we started off with yesterday is going over the fact that I, our imaginary number I, is equal to the square root of -1. We need this to solve some of our different quadratics or higher degree polynomial functions. Now, we went through simplifying radicals yesterday. And we ended up coming up to the fact, or understanding that with these here simplifying, well, the negative is just going to come out as I. The negative will come out of the radical as I, and then we can simplify what's left. So for our square root of 25, well, the square root of 25 is 5. So our square root of -25 is 5i. So we have this here. Now the next one, we went over this here, so the negative would come out as I, leaving us with the square root of 72. Now it doesn't simplify as nicely, but the 30xs will take the square root of 72 for us, telling us that it's 6 square roots of 2. So for us here, square root of -72 would be 6i square root of 2. So it simplifies it nicely for us. And we went through some examples of simplifying these radicals. The next thing we did was powers of I. Now our powers of I, we take the exponent. Whatever the exponent is, we divide it by 4. 0.25. And we'll get a number and a decimal, either 0.25, and if we get a decimal of 0.25,
it's like we're doing it like all the numbers.
Yeah, I'm just kind of going back through it. We get I. Now the 0.50 reduces to -1. Our 0.75 goes to -I. And our 0.00 would be 1. And we would take whatever the exponent is, divide it by 4, and get our answer. So like the first one here, we did this one already. We could take 27 and divide it by 4.
See, I got a square root of 13 I. I didn't know if you put square root of 13 behind I or not.
You put it in front.
Yeah.
Yeah, we want to put the I in front of the radical, not behind it. And it's not so much that it's wrong to write it as the square root of 13i. It's just that the I has a tendency to creep its way back inside the radical. So we put it out front just to make sure that we have it there. If there is another number, we'll put it in front of the I. So looking at this here, our 0.75 tells us that this here would simplify to -I. Now, one of the nice ones with I to know is I squared, because I squared is going to be -1. It's one of the nice ones to know because it's one that does show up a lot, and we do need to reduce it. We can't leave it as I squared. I squared is -1. In our addition and subtraction, we added and subtracted these like terms. And we did a few of these by hand and then realized later that, well, we don't have to. The graphing calculator will do these for us. Now, where we stopped yesterday was this here. We want to multiply these here together and write it in standard form. Now, I didn't specifically state standard form earlier, but standard form is just A plus BI. Real number goes first, number without I goes first, number with I goes second. That's all standard form is. A plus BI. Now, if we look at this first one here, well, to multiply, we're just going to distribute the 4i. We're going to multiply through by 4i. Yes. So I'm going to go through. We'll see these here, kind of how they work out. And yes, we can just type these in. Now the first, it's a good check in and see. Because doing it in the calculator, we'll do it a lot quicker. But we'll see how we get there first. Now 4i times -6, well 4 times -6 is negative 24i. 4i times I, well, we'll have plus 4i squared. Questions on how we multiplied through by our 4i. Now, we're not quite finished with this here because we did multiply through, but the issue comes with the fact that we have I squared.
Everett Johnson, you're needed back in the classroom. Everett Johnson, you're needed back in your classroom.
What class do you even have?
I'll be right back.
So, I squared. We do need to reduce this. We do need to simplify it. Well, I squared is negative 1, because we could divide the 2 by 4. We would get 0.5, which would tell us it is negative 1. So what that means for us here is that we have negative 24i plus 4 times negative 1. And our 4 times negative 1 would be negative 4. Now, to have it in standard form, we need the negative 4 in front, telling us that our final answer is negative 4 minus 24i. And that's it. Questions on this here? We ready for the next one? As for the next one, we're just going to distribute the 15i. So the first thing we can do is multiply 15i by negative 1, which is going to make it, well, negative I, negative 15i. 15i times 2i, well, it's going to be positive. 15 times 2 is 30, and I times I is I squared. And again, we can't leave I squared, can't leave I to a power, so we do need to rewrite that. We need to simplify our I squared, and I squared is negative 1. Out of all the powers of I to kind of keep track of, I squared is nice to know is negative 1. That way, anytime we see I squared show up as in the formula in a problem, we can go on and replace it with negative 1. It'll make things nicer to work with. Well, what is 30 times negative 1? Negative 30. Now we know it's going to go in front because it doesn't have an I, so we can go on and just switch it. We could do those two steps at once, telling us that our answer is negative 30 minus 15i. Questions on this here? We ready for the next ones? So this one here, we don't have a single monomial, a single term times our two terms. But our process isn't really any different, because the first thing we're going to do is distribute the 9. So we'll start off with 9 times negative 4, which is negative 36. 9 times 7i is going to be plus 63i. Negative 2 times negative 4, negative 2i times negative 4, is going to be plus 8i. And lastly, negative 2i times 7i, negative 14i squared. Questions on this here before we move on to the next step? Well, there's a few things we can do here. One is we can combine like terms, because 63i and 8i are like terms, and 63i plus 8i is going to be 71i. Minus 14. Well, our I squared is what? Negative 1. Now, our negative 14 times negative 1 is, well, positive 14. So I did do the multiplication and I moved it next to its like term. Because we could have left it as negative 36 plus 71i plus 14, or we can move the 14 next to its like term, same thing. Negative 36 plus 14 is negative 22 plus 71i. Now for the most part, I we can treat the same as we would if it was just a variable, but the only time it changes is if it gets a power bigger than 1. And we've just got to reduce it down. That's it. Questions on this here? Are you ready for the next one? First thing we need to do is distribute the 4. 4 times 11 is 44. 4 times 8i is going to be plus 32i. That gives us our first part there. Next part is going to be distribute the negative 12i. Negative 12i times 11. Almost negative 132. And lastly, negative 12i times 8 is going to be negative 96i squared. Questions on this so far? We feel good with this so far, yes? Now there is a little bit of a trick that I use, especially with I squared. I squared is what? Negative 1, yes? So what's it going to really do? I squared is just going to change what? The sign with 96, yes? So a lot of times when I'm working these, I squared is just negative 1. It's going to take the sign of that number and change it from positive to negative or negative to positive. The only time this is a little tricky, or not, well, I wouldn't say tricky, we have to pay more attention is if it's just I squared. If it's negative I squared, it's going to turn to plus 1. If it's positive I squared, it's going to turn to negative 1. So we kind of have to actually write a number in. But it still works the same. And part of the reason this is nice as well, we can do two things. 44 plus 96 is 140. 32 minus 132, I. Negative 100i. It takes a lot of the steps out. It simplifies it down. But the other way we could have done this is we could have plugged it in the calculator. In the graphing calculator, the one we just did, 4 minus 12i times 11 plus 8i is 140 minus 100i. It does it for us, and it does put it in standard form. And minus 2i times negative 4 plus 7i. Or even if we look at the one we did before it, 15i times negative 1 plus 2i. Not what I wanted. There we go. We get this here. We get the same answers. I mean, if we wanted to, we could say 9 plus 6i squared. So give us the answer. Might be a little big, but let's say 8. Still works. Numbers get bigger. That's it.